Hello and welcome, ICSE Class 10 students. Now look at this beautiful question. This is a very good competency level question from chapter 1, Force of Physics. So let's read the question. It is question number 8 of this competency series which we are doing. And if you have not watched the previous questions of the series, you can check the link given in the description box. The question says, a 55 kg student is climbing a rope ladder hanging from a helicopter. You can see the helicopter and one man is standing inside the helicopter and he's holding a rope ladder. And at the another end, there is a student who is holding the rope ladder and who is climbing the rope ladder. Very clear, it is written, he's climbing the rope ladder. This boy is climbing, okay? And इसका मास दिया हुआ है कितना 55 kg दिया हुआ है क्वेश्चन में. देखो यहाँ लिखा हुआ है 55 kg स्टूडेंट इज क्लाइंबिंग द रोप लैडर. तो क्वेश्चन को ना सबसे पहले तो तुम्हें अच्छी तरह से पढ़ना है, उसे समझना है. कॉम्पिटेंसी क्वेश्चंस बहुत इजी होते हैं. अगर तुम्हारा कंसेप्ट क्लियर है तुम आराम से कर दोगे. शर्त यह है कि क्वेश्चन को अच्छे से पढ़ो पहले और मतलब को समझो. विदाउट रीडिंग द क्वेश्चन प्रॉपरली, विदाउट अंडरस्टैंडिंग द क्वेश्चन, you will not be able to solve competency questions. So it's very clear, right? This boy is climbing the rope ladder. His mass is given 55 kg. Okay, very good. Now, while climbing, see what is written. While climbing, this student leans 0.35 meter backward from the vertical line of the ladder. Understand what is this? बहुत इंपॉर्टेंट लाइन है. क्या कहता है कि लेट अस, आई एम रीड्रॉइंग दिस ऑन द साइड. लेट अस से दिस इज द वर्टिकल लाइन ऑफ द लैडर. ठीक है, दिस लाइन इज द वर्टिकल लाइन ऑफ द लैडर. हियर यू हैव द पिवट. पिवट को मैंने पी से शो किया है. पिवट मींस दिस पॉइंट, द पॉइंट वेयर द अदर पर्सन इज होल्डिंग द लैडर फ्रॉम इनसाइड द हेलीकॉप्टर. अब देखो अब जो नीचे जो बंदा है, द मैन हु इज द बॉय हु इज क्लाइंबिंग द लैडर, आई एम शोइंग दैट बॉय विद अ ब्लू डॉट. I'm considering this boy as a point object. That is how we need to do it. So here, suppose he's climbing. This is the blue dot is showing the boy who is climbing the ladder. Now, if he is not leaning behind, if suppose he's not leaning behind and he's climbing the rope ladder without leaning behind, in that situation, this boy and this vertical line of the ladder are coinciding. Are you understanding? It's a very important concept. Focus on what I'm saying. मान लेते हैं वो पीछे लीन नहीं कर रहा है, वो अपने बॉडी को इस वर्टिकल लाइन ऑफ लैडर से एकदम चिपका के एज मच पॉसिबल फॉर हिम, वो अपने बॉडी को वर्टिकल लाइन ऑफ द लैडर से सटाकर वो क्लाइंब कर रहा है. जितना हो सके उसके, वो जितना सटा के क्लाइंब कर पाए अपने आप को रोप लैडर के साथ. तो उस सिचुएशन में हिज बॉडी, the blue dot, and this line, the vertical line of the ladder, would be coinciding. And but the question says he is not climbing in this manner. He is climbing rather like this. Suppose this is the vertical line of the ladder and the boy is leaning 0.35 meter backward. वो पीछे झुक गया है. Here is the blue dot. वो अपने हाथों को एक्सटेंड कर दिया है और पीछे ऐसे झुक गया है. Are you understanding? He's holding the ladder and he has leaned behind 0.35 meters. So now this distance has come into the picture. He is at some distance from the line of the ladder. This distance is given 0.35 meter. I hope you are understanding what is this blue dot representing. The blue dot is representing the boy who is climbing the ladder. Okay? And these two diagrams are two different ways of climbing the ladder. The first one is when the boy is not leaning behind. He is sticking himself to the ladder as much as possible and then he's climbing. So in this case, the line of the ladder and the boy are at the same, the boy, rather we can say the boy is vertically below the line of the ladder. But here in the second diagram which I've drawn, here the boy has been shown that he is leaning 0.35 meter backward. So he is not vertically below the line of the ladder. Rather, he is at some distance away, and that distance is given 0.35 meter distance away from the line of the ladder. Now, how does it matter? It matters a lot. It matters a lot. Now you see, I will show you the weight of the boy, which is the force which can cause any moment. We all know that force can cause moment. Force can cause torque. Torque means what? Torque is the rotational effect, the turning effect of any force. So if the weight of the boy is existing, it can create some torque. But let us see this diagram, the first one. Here the weight of the boy is acting vertically downwards. I have shown it with the pink arrow. The mass is 55 kg and the g is 10 meter per second square. So the weight will be 55 multiplied with 10, which is 550 Newton. हमें पता है ना m into g वेट होता है, ये तो बेसिक कॉन्सेप्ट है. वेट इज mg. तो हमें वेट निकालना है बॉय का, तो मास दिया हुआ है 55 kg, जी दिया हुआ है 10 मीटर पर सेकंड स्क्वायर. तो वेट क्या हो जाएगा इस बंदे का? 550 न्यूटन. ये फोर्स को ध्यान से देखो, लुक एट द फर्स्ट डायग्राम. ये जो फोर्स है और इस फोर्स का लाइन ऑफ एक्शन, ये पिंक एरो से मैंने शो किया है. दिस पिंक एरो, दिस वन शोज द लाइन ऑफ एक्शन ऑफ हिज वेट. तो हमें जब हम मोमेंट जब कैलकुलेट करते हैं, how do we do it? The formula is very simple: force multiplied with the distance. Now this is which distance? This is the perpendicular distance from the line of action of force and the pivot. तो ये पिवट से, जो P से मैंने रिप्रेजेंट किया है, और ये लाइन ऑफ एक्शन ऑफ फोर्स जो पिंक लाइन से मैंने शो किया है, क्या उनके बीच में कोई परपेंडिकुलर डिस्टेंस है? नो. इन दिस केस, दिस परपेंडिकुलर डिस्टेंस फ्रॉम द लाइन ऑफ एक्शन ऑफ फोर्स एंड द पिवट इज जीरो. तुम सोच रहे होगे सर, दिस इज द डिस्टेंस, राइट? दिस डिस्टेंस तो एग्जिस्ट, but this is not the distance that we are talking about. We are talking about the perpendicular. D represents the perpendicular distance from the line of action of force and the pivot. इस pivot से इस line of action of force के बीच में कोई distance, कोई perpendicular distance नहीं है, क्योंकि pivot के exactly नीचे ये line of action of force है, तो उनके बीच में कोई distance ही नहीं है. But if you see this second figure, this is actually how the boy is climbing. The weight of the boy is here, in this case also acting vertically downwards, 550 Newton. But in this case, you'll see there is a perpendicular distance from the pivot. In this case, we should not say from the pivot. We should say from the axis of rotation, or from the pivot also, if we say that doesn't matter. So there is a perpendicular distance, this distance. You see, there's a 90-degree over here. There's a 90-degree over here. So this is the perpendicular distance from the pivot, and from the and to the line of action of force. So here the D is existing. And you know that if force exists and also the D exists, both can cause moment. Due to that force, moment would be produced. Whereas in this first diagram, if the boy would have been climbing by sticking his body to the ladder, in that case where the D is 0 or very, very less, in that case, the moment would be 0 because D would have been 0. So force multiplied by 0 would give you 0 moment. So यहाँ पे हमें अब क्वेश्चन में पूछा है, कैलकुलेट द टॉर्क प्रोड्यूस्ड. कितना टॉर्क प्रोड्यूस होगा अबाउट द टॉप सपोर्ट पॉइंट ऑफ द लैडर ड्यू टू द स्टूडेंट्स वेट. तो कितना टॉर्क प्रोड्यूस होगा? नाउ यू नो इट वेरी वेल. टॉर्क या मोमेंट का फॉर्मूला इज वेरी सिंपल. फॉर्मूला अप्लाई करना तो इजी है, बट इस कॉन्सेप्ट को समझना वो चैलेंजिंग था. और आई होप यू हैव अंडरस्टूड बाय व्हाट आई एक्सप्लेन्ड. तो हमें यहाँ पे मोमेंट हमें निकालना है या टॉर्क हमें निकालना है. टॉर्क का फॉर्मूला फोर्स टाइम्स डिस्टेंस. फोर्स कितना है? 550 न्यूटन. डिस्टेंस कितना है? डिस्टेंस 0.35 है मीटर. ठीक है. सो यू नीड टू मल्टीप्लाई बोथ ऑफ देम एंड यू विल गेट द रिक्वायर्ड टॉर्क. It should give you 192.5 Newton meter. Now, due to this torque being produced, so what will happen? This rope ladder will start swinging like this, sideways, like this. So it will start swinging. Okay, you can see the black arrows which I have shown. In this manner, it will start swinging to and fro, and it will become very difficult for the person to climb because it starts moving, swinging. So it becomes difficult, obviously. So that's the reason that is why he should not climb in this manner. So if he wants to minimize the swinging, he should minimize this distance, 0.35 meter. He should minimize this distance. This distance should not be zero. I mean, this distance should be zero. Should be zero. He should stick himself to the line of the ladder so that this distance becomes zero, and so the torque also becomes zero. Anyway, let's come to the second part of the question. Let's read what the question is telling. Explain why the ladder starts swinging when the student leans backward. You know why what happens, and how he should climb to minimize the swinging. That also you know. So how will you write in the answer in the exam? When the student leans backward, the line of action of weight shifts away from the vertical rope. So vertical rope से उसका जो line of action of weight है वो backward shift हो जाता है, and there exists some distance. Now this creates a torque about the top support, causing the ladder to rotate. Hence, it starts swinging. Understood? Now, how should he minimize the swinging? The student should keep his body close to the ladder. As much as possible, he should bring his body close to the ladder so that the D becomes very, very less. It becomes zero. And if not zero, it becomes a very small value so that the moment can be minimized significantly. So this reduces the perpendicular distance when he sticks himself to the ladder and then he climbs. So this reduces the torque, resulting in less swinging or maybe no swinging. So in this question, it says, how do we reduce the swinging? So we can say that he can reduce the swinging by keeping his body close to the ladder. Okay? So this was really a very good question, and I hope that you have enjoyed this question. Okay. So we will see in the next video. And if you want to continue with the series, you don't want to miss any of the videos, you should subscribe to the channel if you have not done it yet, and also press the bell icon. Okay. Take care.